hope you are finding the difference between linear and exponential, okay? Just remember the exponential always talks about percentages, all right? So we're going to do a problem, okay, that describes two situations, and we need to figure out which one is in linear and which one is in exponential. All right, so it says, as part of his biology project, Lewis is observing the growth of two plants. Plant A had an original height of 5 inches and is growing 1.5 inches per week. Plant B had an original height of 3 inches and its height is increasing by 45% each week. Define the variables and write a function that represents the growth of each plant. Alright, first thing is first, we need to find our independent variable and dependent. And in case we forgot, because I'm pretty sure we're going to forget, independent variable is your x variable. Your dependent is your y. Remember, x doesn't need of anything. It's independent. Y obviously needs of x in order to change. So that's why it's your dependent. Okay, let's look at the problem. They're both talking about the original height, okay, and the growing for each week or per week. So which of these is going to be x and y? I don't know if you guys remember, but I told you that x, anything on the x-axis, anything on the independent variable, since we are talking about a graph here, your x values go on the bottom, your y goes on the left side, that goes up and down, okay? Your x will always, please remember this, we'll be talking about the time. Well, which one of these are talking about the time, the height or the week? Okay, that means that we're doing the week for independent per week. How many weeks is it going to take? And y has to be the total height. All right, now that I know what your variables are going to be, now we need to write the functions. We need to write a function for plant A and plant B. Just by looking at those two situations, plant A and plant B, which one do you think is going to be an exponential function? Good. You should have noticed that plant B is going to be exponential just because of that little information that they gave me that it was going to be by 45%. Remember, percentage is for exponential. So plant B, again, how do we write an exponential? Y equals A times B to the power of X. How do you write an equation, in linear equation? Y equals mx plus B. All right, here we go. Let's write the function for plant A. Y equals, again, m is the slope. How much is it changing per week? It's changing 1.5 inches. So it's going to be 1.5x plus your B is your y-intercept, your initial, which in this case is your original height, which is 5. And that's it. Plan B. Plan B is y equals, okay, A is your initial. A is your original height, which is 3 times B. B is the change, the rate of change. Again, it's set increasing by 45%. That means that we're going to be adding, okay, 1 plus, and remember, 45%. We're not using the percentage, we're using the decimal, which in this case will be 0.45, because you forgot how do you get the 45% as a decimal. You divide by 100. And then obviously we have our x as our exponent. The time will be the exponent. So my final formula function for this is 3 times 1.45 to the power of x. And that's it. That's all we're doing, okay? We're distinguishing between, again, linear and exponential function, which is our objective for this target.